Okay, and lastly, part 4. So here we have polyatomic ions, meaning there are many atoms, so more than one atoms, and these are ions, meaning they have lost or gained an electron or two. So here we have carbon and nitrogen, and then the little -1 is the charge. And you know that the charge on the electron is -1. So what this indicates is there is an extra electron. So when we go to write out the number of electrons, here's how we're going to do this. We're going to write carbon, which is 4. We're going to write nitrogen, which is 5, and then we're going to say +1. And the +1 is because this, and I know you look at the signs and you're like, wait a second, that's opposite. But this is referring to the charge of this. This is referring to how many electrons. So these are basically the same number but opposite, because electrons are negatively charged. So the total number of electrons is 10. 10e, okay, 10 electrons, so we're looking for 5 pairs. Okay, draw out the carbon, draw out the nitrogen, just like we were doing previously, where we assume carbon will share 1, and that's probably not right. When you see this electron all by itself, a free radical, it's usually not the way it works, but let's see. Nitrogen has 1. Nitrogen has 1, 2. Nitrogen has 1, 2, 3, 4, 5. And counting them up, well, I'm sorry, and then we have this additional electron, okay, this guy. So maybe we'll draw him in there. Maybe that electron is a her, who knows. Count them up. Carbon has 6, nitrogen has 6. Okay, so that's pretty close. It looks like that if we were to bring in, let's see, then each would have 7. Bring in another electron, then each will have 8. And so we just kind of know that from our previous experience. So we have carbon sharing 1, 2, 3. Here's its 4th. Here's that random extra electron. And over here we have nitrogen sharing 1, 2, 3, and then having its lone pair. So we're going to have a triple bond between carbon and nitrogen. Lone pair, and when we count them up, we have 2, 4, 6, 8 surrounding nitrogen, and 2, 4, 6, 8 surrounding carbon. The actual structure then is drawn like this. Carbon triple bonded to nitrogen, a lone pair of a lone pair of electrons and a lone pair of electrons. Okay, disregard this line here, that was a mistake. Okay, number 2, PO4 -3. So we have phosphorus. Again, I'm adding up the electrons first. Phosphorus has 5 valence electrons. Oxygen has 6 valence electrons, and we have 4 oxygens. So oxygen, oxygen, alright, there's 4 of them. 6 valence electrons each, plus a charge of -3 indicates that there's 3 extra electrons. So I'm going to say +3. And adding all those up, 24, 29, 32. So we have a total of 32 electrons, meaning we're looking for 16 pairs. And we're going to assume that phosphorus is the central atom and the oxygens surround. So let's see. Phosphorus, oxygen, 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 oxygen. And phosphorus is normal 5. Let's see. 1, 2, 3, 4, 5. And so I'm just drawing that out, and we're going to see how this works. Okay. I'm putting individual electrons, like this, assuming that it's going to share with the oxygen. And look at what happens with the oxygen. Oxygen has 6 valence electrons. So if we do 1, if we do 1 and then 2, 3, 4, 5, 6, again we're ending up with this single electron. And that occasionally it happens, but not very often. All right. So what if we... So I'm just trying to save some time here, okay? We could do this for all the oxygens, and then we'd count up, and phosphorus looks like it'd be happy, okay, with all these 8 electrons, all right? Oxygen only has 1, 2, 3, 4, 5, 6, 7. So this is where this comes into play. We have these 3 additional electrons. So I'm going to do just what I did for the oxygen, okay? We have 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. And then for this guy over here up top, 1, 2, 3, 4, 5, 6. Because there are already 2 electrons here, so that will form a bond between these guys. And then these extra 3 we can fill in, making a nice pair, and a nice pair, and a nice pair. So for oxygen, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And over here, 1, 2, 3, 4, 5, 6, 7, 8. So what we're seeing here is that where the electrons come from doesn't really matter. It can be these extra 3, and we can plop them in here. We could have put them here. And the fact that this oxygen over here is now bonded to the phosphorus, and these original 2 electrons were from the phosphorus, doesn't really matter. All that matters is that each atom is surrounded by 8 electrons, and in whether they are that atom's own or they're sharing, it doesn't matter, the atom will still be happy. The structure, therefore, will look like this. Phosphorus as the central atom, all these oxygens sticking off, and remember each of them has 1, 2, 3, 4, 5, 6 valence electrons, so don't forget to draw those in. I wonder if I forgot on the previous example. I don't think so. Alright, so it would look like that. Oh good, we have the valence electrons. Alright, OH, -1, this is the hydroxide ion, it's called. Oxygen has 6, hydrogen has 1, and then we have this +1. Again, that's the charge, indicating there is an extra electron, and we have a total then of 8 electrons. We're looking for 4 pairs. Okay, 4 pairs. Oxygen, hydrogen. Let's see, hydrogen has 1, oxygen has 1, 2, 3, 4, 5, 6, and lo and behold, this extra guy, if we put it right here, oxygen is all of a sudden happy. 8 surrounding oxygen, and again hydrogen, because it's in that first energy level, only wants 2, and these look good. Oxygen to hydrogen, so these 2 electrons form the bond. And oxygen then has 1, 2, 3, 4, 5, 6 valence electrons hanging out around it. The Lewis structure. Okay, so there's number 6, number 5, number 4. Alright, there are a bunch of these. I'm going to do one more and then let you do the other 5. Okay. So number 4 looks like this. SO3, -2. Sulfur has 6 valence electrons. Oxygen, oxygen, oxygen. Again, there are 3 oxygens. So oxygen has 6 as well. And then we have an additional 2 electrons, so plus deuce. 1, 2, 3, 4. 24 plus 2 is 26. So 26 total electrons. We're looking for 13 pairs. And we're going to assume that sulfur is the central atom with oxygens hanging out around it. Notice how there are 3 oxygens. Sulfur having 6, oxygen having 6. Aha, okay. So let's say sharing, sharing, sharing. 1, 2, 3. Well, there are 6. So it's probably going to be double bonded. Let's draw all 6 of those sulfur electrons like this. Okay. Oxygens, 1, 2, 3, 4, 5, 6. And so I chose to do that because there's already 2 here. So if the 6 go out here, then this oxygen is surrounded by a total of 8. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So oxygen is happy. Oxygen's happy and oxygen's happy. If we look at sulfur, it is only surrounded by 6. And that's where these come into play. So these extra 2 we could put here as a lone pair. Sulfur now feels like it is surrounded by 8 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. Everybody's happy. And our structure would look like this. Sulfur, oxygen, oxygen. Sulfur has a lone pair hanging out. Oxygen, each of the oxygens has a total of 6 valence electrons. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so this video is running out of time. I want you to do 5, 6, 7, 8, 9, and maybe we'll have another video showing you those answers. But see what you can do. Add up the total number of electrons and go for it.